Hi, everybody. It's Professor Mitchell. We are finishing up Chapter 5 today on decimals by looking at some decimal applications, namely the mean, median, and mode. So this will be really useful for those of you who will be going on to take statistics. The objectives in this section are to find the mean or average of a list of numbers, and then find the median of a list of numbers and find the mode of a list of numbers. So the mean, median, and mode are all examples of what are called measures of central tendency. And the idea behind that is sometimes we want to summarize data by displaying them in a graph, but sometimes it's also desirable to be able to describe a set of data or a set of numbers by a single middle number. And the three most common examples are the mean, the median, and the mode. Out of those three, the most common is the mean, which is also called the average or sometimes the arithmetic mean. There are a couple of other kinds of means. You don't see them too often unless you're a math major. So we'll just talk about the arithmetic mean. And you've probably seen this before. The mean or the average of a set of numbered items is the sum of the items divided by the number of items. So for example, if you're trying to find the mean of some test scores, you want to see how you're doing in a certain class that you're taking. If those test scores were 87, 75, 96, 91, and 78, for example, there are 5 numbers there. So what you would do is add all those numbers together and divide by 5, since there are 5 of them. Those 5 numbers add up to 427. 427 divided by 5 comes out to 85 and 4/10. So that would be the mean or the average of these test scores. So if your grade in this class was based solely on your scores on these 5 tests, you would probably get a B in this class. Here is a more sophisticated example of finding the mean, and that is finding the grade point average. Grade point average is an example of what's called a weighted mean. So for example, let's say that you were taking 5 classes and your grades in those 5 classes were an A, a B, a C, a D, and then another A. And the number of units of those classes were 2, 4, 5, 2, and 2. So the idea behind a weighted mean is that the 5-unit class should count more than the 4-unit class. The 4-unit class should count more than the 2-unit classes. So the way that we do a grade point average is like this. First of all, we need to know the point values for the different possible grades. So the most common system is that an A is worth 4, a B is worth 3, a C is worth 2, a D is worth 1, and an F is worth 0. So what we're going to do is next to each grade, we're going to write down its point value. And then we're going to factor in the credit hours, which is the number of units for that class. The way that you find the point value for each class is by multiplying the point value of the grade by the number of units. So let me bring my pen up here. So for example, in this first row, you're going to do 4 times 2 equals, and I'm going to put an 8 over here. And then I'm going to do the same thing times 4, and that's going to come out to 12. So when I click on this, there's the 8 for the first class, there's the 12 for the second class, the rest of them are going to be 10, 2, and 8. So now what I'm going to do is add up all of those point values and add up the total number of units. So this person was taking 15 units and they got a total of 40 points for all of their classes. So the way that we're going to find this weighted mean is we're going to divide the 40 by the 15. And so this person's GPA would come out to be 2.66666. GPAs are usually rounded to 2 decimal places. So this person's GPA would be 2.67. All right, that brings us to the median. One disadvantage of the mean is that it is greatly affected by unusually high or unusually low values. So think about, have you ever taken a class where there's that one student that gets 100% on every test, all right? And the other students in the class might give that person a hard time and say, hey, you're throwing off the curve for the rest of us. Well, that's kind of the idea. So let's say that your class took a really, really hard test. And of course, that person got 100%, but then the next highest score was a 70, all right? And if the instructor was trying to find the mean for that class, let's say there were 10 students in the class. So they add the 10 scores together and then divide by 10. That person's 100% score is going to bring the mean up by a few points, all right? So in a situation where you have unusually high or unusually low scores, in my opinion, the mean is not the best measure to use. And what I prefer to use is what's called the median, okay? So just like we were just talking about, you may have noticed that a very low number or a very high number can affect the mean of a list of numbers. Because of this, you may sometimes want to use another measure of central tendency called the median. The median of a set of numbers in numerical order, that's really important, is just the middle number, all right? You arrange the values in order and just pick out which one is right in the middle, and that's called the median. So in the example of the class with 10 students, let's say the highest score was 100 and the second highest score was a 70. If that 100% score was changed to a 75, it would not change the middle number. So the median is not affected by unusually high or unusually low scores. It's just whichever score lands in the middle, okay? Now, there is an issue with if the number of items, the number of values is odd, then there will be one right in the middle. So let me just show you a quick example here. Let's say that the 5 values were 13, 20, 30, 45, and 52, all right? You can see, and I did put them in order, that the 30 is right in the middle, all right? There is undisputably one middle number, and that's the 30. However, oops, if I added another value to this, let's say 60, well, now there is not one score right in the middle, there are 2 scores right in the middle. So what we do in that situation is just take, sorry about that, take the 2 that are in the middle, so in this case the 30 and the 45, and take the average of those 2, the mean of those 2. So let's look at a couple of official examples. All right, so if I had these numbers, 2 and 5/10, 5 and 1/10, 9 and 5/10, 2 and 5/10. The first thing I'm going to do is arrange those in order. And in order, those numbers look like this. And since I have an odd number of them, there is clearly one right in the middle, and that is the 5 and 1/10. So that would be the median. All right, here's another example. I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So this is going to be one of those where we take the middle 2. First, I have to put them in order. Don't forget to do that. Okay, so those numbers in order look like this. The two in the middle are the 78 and the 88. So I'm going to take the mean or the average of those two. And remember, that means add them up and divide by 2. So when you add 78 plus 88 and then divide by 2, you get that the median is 83. So the interpretation of the median is that half of the scores are less than or equal to 83. Half of the scores are greater than or equal to 83. All right. So the median gives you a boundary between the top half and the bottom half. All right, finally, the mode. The mode of a set of numbers is just the number that occurs most often. This measure is probably the one that I use the least often. If you ever take me for statistics, I'll explain in a little bit more detail when do I actually use the mode. All right. It is the number that occurs most often. Note that it is possible for a set of numbers to have more than one mode or to have no mode. Okay. So here is, I believe, the same set of numbers that was our first median example. So when you're finding the mode, it's not necessary to put the numbers in order. It might be helpful if you had a bigger list of numbers. Just to, it might make it a little more clear which one occurs the most often. In this case, it's easy to see that 2 5/10 is the number that occurs most often. So that would be the mode. All right, here's another example. They want me to find the median and the mode. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers there, an even amount. So this is going to be another one of those situations where I'm going to take the average of the middle two to find the median. 18 plus 26 is 44. 44 divided by 2 is 22. So that's the median. And when these numbers are listed in order, it's easy to see that the one that occurs most often is 15. So that would be the mode. And then finally, don't forget it is possible for a list of numbers to have no mode. So for example, in the case where each number occurs only once, you would say that that has no mode, okay? Now, I'll just point this out really quick. Let's say there was another 2 and another 9. So there were 2 2s and 2 9s. Usually in that case, we say that the 2 and the 9 are both modes, all right? If you have 2 numbers that are tied for occurring the most often, then we usually do say that those are both modes. Now, if there are 3 numbers that are tied for occurring the most often, then it kind of depends on which book you're reading. Some books will default back to no mode. In that case, other books will allow all 3 of those numbers to be modes, all right? If you have a bunch of ties between different numbers, especially if there's more than 2 numbers that are tied, the mode is really then not all that useful, all right? So just focus on the case where there's 1 mode, maybe 2 modes, or no mode. And that's the end of section 5.7, and that's also the end of chapter 5.